recording. Okay, so let's get rolling. Hopefully everybody had a miserable weekend doing this homework. Apparently I've been told it takes 48 hours. So let's take a look at it. Today we want to cover reading something in from the user. We also want to cover loops because I've already put the homework assignment up covering loops, and we got to cover everything that's on that assignment. Otherwise, it's going to take way more than 48 hours to do the next one. All right, so let's take a look here. Controls. All right, so here's homework 2. We're working with Boolean variables and if statements. Supposed to be practicing these things. Keep in mind that all this stuff is going to kind of come together. We're learning about tools. You can kind of think about this like we went to Home Depot and we bought a bunch of tools. We're looking at the instruction manual and we're kind of practicing using those tools so that we can now take it and apply them to a real project. All right, that's kind of what we're doing right now. All right, so we're supposed to be working with Boolean variables. We're supposed to be creating some if statements. So they wanted us to define a couple of Boolean variables. I'm actually just going to steal those 2 lines. We'll go over to this guy. Let's choose C++. All right. So as usual, I'll go ahead and run this, make sure we're getting a hello world. We are. So I'm going to go ahead and define those couple of variables. And let's see, is it? Yeah, it's cool like that. All right. So we defined a couple of variables, is sunny and is raining, set them to true and false as per the homework assignment. Now let's see, what does it say to do next? Okay, we want to write something out to print the values of these variables. So practicing with cout. Remember that if you do not say using namespace up here, if you say using namespace std, then you won't have to say something like std : cout. You would be able to just say cout. All right, so we're going to write out is sunny. And we'll write out is raining. So we should get a true and false to the screen here. So there's our 1 and our 0 representing true and false. All right. So we're going to keep trucking. Define a Boolean is weekend is true. And then, so I'll go ahead and copy that. I'd encourage you to limit the number of times you copy stuff and paste it in. You'll want to practice typing the stuff so you kind of see what your tendencies are for mistakes. Are you prone to forgetting semicolons or things like that? Once you've done it enough times, then you can copy and paste stuff like this. But just don't be your worst enemy. Let's see, somebody else's. All right. And again, for you online people, if you log into Zoom using your Concordia credentials, you will not get put into the waiting room. It'll let you right into the class. So when you go to Zoom, you want to click on that SSO login, and that will allow you to log in using Concordia's, your credentials with Concordia, and then you'll be an official user. Otherwise, you're at the mercy of, do I see that you're in the waiting room? Especially if you're not at class at the very beginning. Okay. So is weekend. Throw that guy in there. All right. And then we want to write an if statement to print it's the weekend if is weekend is true. All right. So this is the string we're going to print out here. One little hint I'll tell you for future reference. Sometimes when you're copying and pasting stuff that has double quotes in it, it'll copy the wrong kind of character. It's kind of like a weird 2 tick marks instead of actual double quotes. So if you ever have copied copied a string in like that, and you get weird results, go and just backspace the double quotes and retype them in yourself, and it'll probably fix that problem. Just a heads up. Okay, so we want to ask a question. If is weekend is true, then we want to print out it's the weekend. Okie dokie. So we'll write our if statements here. If is weekend is equal to true, and we're going to talk about that here in a second. Then we'll want to output it's the weekend. All right, we'll go ahead and test this. So since is weekend started off as a value of true, it will be true here. Therefore, we will display it's the weekend. So there's our it's the weekend. If we were to test our if statement and switch is weekend to false and run it again, we'll see that it won't print out it's the weekend. All right, so that's us asking a question and responding to it. All right, so now remind me, what's a Boolean expression? Any expression that boils down to a single value of true or false. Is that a Boolean expression? If is weekend is just saying is weekend, is that a Boolean expression? What's the value of is weekend? True. Is true a single value of true or false? Absolutely. So this will give me the exact same output. Now, the reason I show it to you this way, if is weekend will give you the identical result to saying is weekend equivalent to true. And the reason for that is if is weekend is true, this is saying is true equivalent to true, which is always a true statement, right? They're the same value. If is weekend is false equivalent to true, which is always a false statement. All right. So when you are a more experienced programmer, you will probably trend towards this type of way of writing this Boolean expression. Since is weekend is a Boolean value, you don't actually have to say is weekend equivalent to true. You can just say if is weekend, because it'll have the same result. Now, having said that, if you don't like that, that's uncomfortable for you, or just for whatever reason, there's nothing wrong with throwing the equal true on there. It's we are kind of repeating ourselves. We're asking is true equal to true instead of just is true. But if you like the way that looks better and it makes sense to you, use it every time, even though technically it's redundant. Go ahead.
Can you just use a single equal sign?
No. Tell me why. If I use a single equal sign there, why is that bad? What's the difference between the double equal sign and the single equal sign? Common mistake. I mentioned it last class, right? Okay, so you're going to keep hearing me repeat those things, the pitfalls that beginning programmers run into. What's the difference between a double equal sign and a single equal sign?
Oh,
Okay. So you're talking more about kind of the results. I'm talking about the operators themselves. If we go back to our presentation, I'm sure I have it somewhere in here where we compare the double equal sign, which is the equivalence operator, to test if something is true or false, to see if two things are the same, resulting in a Boolean true or a Boolean false. Whereas the single equal sign is the assignment operator, where we assign the value on the right-hand side of the equal sign to the variable on the left-hand side of the equal sign. All right. So the reason why you probably are asking that question is when you wrote it like this, it was still cool with it. Why was it still cool with it? Nothing about what I said is a lie, and it completely adds up to this. What I have highlighted there, what is actually happening? When I say is weekend equals, I usually will read that as gets the value. A single equal sign, the assignment operator, I'll often read that as gets the value. Is weekend gets the value of true. What is happening in that case? Just with what I have highlighted. Forget about the if statement for a second. Is weekend equivalent to true does what? Yeah, I'm overwriting the current value of is weekend with the value true, which happens to be the same value that used to be in there. Okay, and we can see that the evidence. So if I put a false in there, we would have expected the previous behavior to not print this out, right? We started with a false, but we'll see it does print it out. All right, because why is it doing it? It's before we execute the if statement here. What happens in here gets resolved. So this is setting is weekend equal to the value true. It's overwriting that false with a true. And then variables resolve to their value. So ultimately, this will boil down to a single value of true or false. But it also actually changed the value of is weekend. Make sense? Super important concept there. So go back and listen to the video multiple times if that doesn't quite make sense to you. Single equal sign always changes the value of the variable on the left-hand side. That's what it does. If you don't intend on changing the value of variables, don't use the single equal sign. If you are instead testing whether things are equivalent, you use the double equal sign. That's the primitive equivalence operator. You don't have to worry about what the alternative equivalence operator might be. We'll talk about that when we get into strings. But for right now, if you want to test for equivalence, it's a double equal sign. If we want to change the value of a variable, it's a single equal sign. Okay. But the reason why you were confused on this is because ultimately variables do resolve to their value. So kind of two ninja moves were happening in here. First ninja move is we were changing the value of is weekend to true. The second ninja move is it resolved to the final value of is weekend, which happened to be true, which is a Boolean expression, which is compatible with an if statement. Make some sense?
Hang on. So how do we properly change it so that it recognizes it's false and that it doesn't print it out?
Double equal sign. We're asking, is this variable equivalent to this value? We know that its current value is false, so now it will not print it out.
I think when I tried that out, it still printed it out for whatever reason.
I promise you it was because you did something a little bit different than what I'm just displaying here. If you can get it behaving that way and email it to me, I'll tell you why it's giving you that output. But one thing to keep in mind is even though you might have weird quirkiness and stuff like that with the website, somebody was saying they were getting a weird font issue and stuff. I promise you, if you're getting a result that isn't the result that you think it should be, it's because of the syntax you wrote. If you're getting output, it's not like the compilers make mistakes. Okay? But it's common. Go ahead.
I set is weekend to false, and then I wrote that same Boolean expression, but it's still outputted as true.
Well, I'd have to see the Boolean expression. My guess is what you're calling the same Boolean expression isn't quite the same. There must be a little tiny difference in your code that isn't quite obvious. Just trust me. If you do the code identically, it'll give you this result. The result you're getting that you're confused about probably has a lesson built into it as to why it's giving you that result, but there is going to be some tiny little difference between what I'm doing here and what you've written, even though at a glance it looks identical. This is normal for beginning programmers. You write something, I mean, it's very common for students to come to me and say, oh, I did exactly what you did in class, but I got a different result. Promise you with 100% accuracy, you didn't quite do exactly what I did in class. You had a little tiny deviation somewhere, or maybe another common mistake is people sometimes will accidentally put a semicolon at the end of an if statement or a loop. you know, which is easy to overlook that, right? Especially when you
Yeah.
start writing a
Yeah,
lot of,
no, I found it. I
okay.
found it. That's what I did wrong.
Yeah. But I mean, this was a good question. So I didn't mean to like kind of attack you. It was more like, this is a very common mistake. All right. This type of thing. I'm just giving you that baseline that if you think you've done the same thing that I've done in class and you're getting a different result, I promise you, you've done something a little different. All right. And that's part of that skill of learning how to debug. Go ahead. These guys? Okay, so that goes back to what we talked about last class as well. Technically, the syntax for an if statement is if Boolean expression followed by a single statement. In this case, since we're only doing a single thing, you do not need the curly braces, but I'm telling you, it is never, ever, 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 ever wrong to have the curly braces there. So if I were you and you wanted to be less error prone, I would always put the curly braces there, even if you're only going to do one thing, because at the very least, it makes your code look more structured and it's never incorrect. Basically, what you're saying is for my mind, I'm going to change the definition of an if statement for instead of it saying if Boolean expression statement, I am always going to do if Boolean expression block statement, which is a collection of 0 or more statements. Then you don't have to worry about the difference. It's important to understand what's going on there, that difference between the curly braces and not. I'll never test you on that, but I'm basically telling you in your entire career, you won't have to screw with it if you just always use them. All right. Okay, so that's the deal with that one. Like I said, this part here is actually redundant. You don't need to say is true equal to true or is false equal to true. You could just say if this Boolean variable. But if you don't like that, if that just feels uncomfortable, put the double equal sign in there and compare it to the value you want. Who cares if you're a little bit redundant? Computers are really fast. Okay. So right now it's not going to print it because I started off as false. If I switch it back to true here, now it will print it. Okay. So chugging along. Let's see, what did I just do? I just did this guy here. All right, so Boolean expressions with operators. Oh, we're using the and operator. So we were talking about Boolean stuff last time. Remember, we talked about the single ampersand and the single vertical bar, sometimes kind of tricking you because it's doing a mathy thing, but it's not doing what you think it should be doing. Okay, so we're going to define a couple of variables here. Again, you should probably be typing these to see what your errors are. All right. And then this guy says to write an if statement that checks if it's raining and you have an umbrella. If both of those things are true, then you want to print, you can go outside with an umbrella. Here, I'm going to see if I can actually force that error that I showed you before, that I mentioned before. All right. So if both of those are true, so we're going to ask the question, if have umbrella and is going outside. See out. Yeah, this is going to give us the error. Notice here that when I have the correct double quotes around it, it highlights it in green on online GDB. And notice down here, when I cut and paste the double quotes, notice it didn't turn green. It's because this character right here is technically a different character than that guy. That is a common thing to happen when you like copy out of a web page or something like that. Okay, so something to keep in mind if you're copying a string or something that, I mean, the fix for this is just to go in here, backspace it, put your own double quote in there. Just retype the double quote with the correct thing. Go ahead.
So when you're doing print stuff like the COUT, do you want to have a space between like the arrows or? do
This
you-
guy, you mean? It's not required, but I usually would, because you want this to be more readable. Okay, so this gets down to the question of personal preference versus what will C++ let you get away with. C++ is perfectly cool with you putting your entire program on one big long line. Impossible for a human being to read, but it's fine with it. Good. Is it? Let's see. If it's raining and you have an umbrella, okay, so we already defined is raining up here. So if we have an umbrella and it's raining, if both of those are true, and like I said, if you prefer to throw the equivalent to true in there, if you like the look of that better, that's okay, even though it is redundant. So if both of these things are true, then we'll say you can go outside with an umbrella. Right now, have umbrella is true, and is raining is false. So this is a true and false, which is a what?
True.
True and false. Both sides need to be true. This is a false statement, right? One of them is true, but the other one is false. So anything and false is false. So this is saying if the current value of have umbrella, which is true, and the current value of is raining, which is false. True and false is false, so we will not see this line displayed. It's printing out it's the weekend, but it did not print this out. If instead we come up here and we change is raining to true, now our Boolean expression is true and true, which is true. Now it will print it out. There's you can go outside with an umbrella. Make some sense? So a lot of rinse, lather, repeat stuff here, drilling. I promise you'll thank me later. You'll have less errors, but you'll still have a billion errors. Okay. So let's keep cooking. The or statement, write an if statement that checks if it's sunny or the weekend. If either is true, print it's a great time to relax. All right, so we're working with the variables if it's sunny and if it's the weekend. If either one of those things are true. So if, here's our is sunny, or is weekend, then we'll see out. All right. So if either of these guys is true, or both of them, if it's sunny and it's the weekend, even better. But if either of those guys is true, the whole thing will be true. Currently is sunny is true. So we know that we can even just stop. We don't have to check if his weekend is true or false. Because an or fires true if either side is true. Okay, so this is true or whatever his weekend is, which also happens to be true. So this is true or true, which is true. So we'll get it's a great time to relax. There's our, it's a great time to relax. If we change just one of those things to a false, we'll see that it still will display it's a great time to relax because an or only requires one of the things to be true in order for the whole thing to be true. So it's still it's a great time to relax. But if we change both of them to false, so it is not sunny and it's also not the weekend. Now we're saying false or false, which is false. So it will not display it under those circumstances. All right, makes some sense. All right. All right, not operator. We're gonna create a variable called is tired, set it equal to false. Then we're going to write an if statement that checks if the person is not tired. And if true, it'll print out the string. So if they are not tired, we're going to do that. So now this will actually help explain a little bit what I was talking about earlier about that redundancy thing, because you're going to kind of see two versions of it here. Okay. So we're going to write if not is tired. If it is true that not is tired is true, we will see out that guy. Now, not is tired is the same thing as saying is tired equal false. It means the same thing as that. Remember the not operator, this exclamation point, it flips a Boolean. So not true is false, not false is true. Okay, so this is saying if not tired or not is tired, then we'll print this guy out. Is tired is currently false, not false is true. So we'll print out you have energy to go for a walk. There's our you have energy to go for a walk. We can see that we can write it the other way as well. If we prefer that, we can say if is tired is false, also print it out. The logic is identical. Now, I would say it is reasonably important to understand that not operator. So I would say most of the time you'd like to write it this way, because that not operator is something that's going to come in handy in a lot of different situations. But if at this point you just hate it and you really like just saying things, if this is equivalent to this value, whether it's true or false, write it. Write it the way you're most comfortable with. One day it'll click and you'll update your preferences. Okay. Modify your is sunny and is raining variables. We want to set is sunny to false and is raining to true. So let's go back there. Here is sunny to false, is raining to true. So we were testing it, so we've already switched it to what it wanted us to switch it to. All right. Write a series of if else statements and else statements to handle a series of if, else if, and else statements. Else if is a good one to talk about for a second too. That's related to his question about the curly braces. Let's see. If it's sunny, print wear sunglasses. Okay, so we'll steal this guy. So only if it's sunny are we going to print out wear sunglasses. If is sunny, see out that guy. All right, and right now is sunny is false, so it's not going to print that. So we will not see wear sunglasses. All right, next one. If it's raining and you have an umbrella, print take your umbrella. Raining and umbrella. If is raining and have umbrella, see out that guy. So right now is raining is true, and have umbrella is also true. True and true is true. Therefore, it will print out. Take your umbrella. There it is right there. Next, if it's raining, but you don't have an umbrella, print you might get wet. If is raining and not have umbrella. See out you might get wet. If it's raining and you do not have an umbrella, that's what that guy says, then we're going to print out you might get wet. But in this one, it wants to have an otherwise. Weather looks unpredictable today. So we're going to throw an else on the end of that guy. So we're going to have an else. So right now, is raining is true. Have umbrella is true. So this is saying if true and not true, which is false, right? So if true and false, which is a false statement, we would print out that, but in this case, since it's false, we won't. We're going to print out weather looks unpredictable today based on the current variables. There's our weather looks unpredictable today. And what I'll do here is at the end, I'm going to be showing you, so somebody try to remind me. I want to show you how to share your code. I'll put the link to this code up on Slack. So you have it, because that's the way I'm going to have you start submitting your homework. Now that our homework's going to start getting a little bit longer, rather than you pasting a bunch of code that's hard to read into Blackboard, I'm going to have you put the link in. Okay. But now you appreciate that having the link, right? Go ahead.
I was just up earlier, yesterday, I kept using the code else if, is else if the right way to use the code, or do you just want to use if?
The answer is yes, it's right, but probably for a different reason you're thinking. I'm going to talk about it here within the next 5 minutes.
Okay.
So if I haven't answered your question, then ask it again.
Okay.
All right. So hopefully this next one has a, do we have an else if somewhere in here?
Yeah, I was gonna say for 3.1, isn't the point that you're supposed to say one of the 4 options? So if the weather's unpredictable, you don't know.
Yeah, it looks like I skipped this one, right? Yeah, I skipped over a line. So we'll go back and add it in here. See, I can program, but I can't read instructions. Hey, so I'm never going to be right either. All right, so if it's sunny, we're going to print. Oh, hold on, are we even there yet? All right, is sunny, is raining. Okay, write a series. Okay, we already have to wear sunglasses, right? Let me just catch up. Wear sunglasses here. And yeah, so we're here. So I have you might get wet. Otherwise, printout looks unpredictable. Okay, so I haven't messed up yet. We're good so far. All right, so now we're going to use a combination of those guys. So we're going to write an if statement that checks if it's both sunny and the weekend. We're going to print out perfect day for a picnic. So we're going to write that guy. So this 3.2 is having us mess around with an if, an else, if, and an else. Okay, and I'm going to write that else if 2 ways, and you'll see what I mean, because it actually, the common way to write it goes against my advice of always using the curly braces. And you'll see what I mean here in a second. So if it's sunny and the weekend, that's the first part we're writing here. If is sunny and is weekend, see out perfect day for a picnic. All right. Adding to that, add an else if to check if it's either sunny or the weekend. We might say it's a nice time to go out. It's still a nice time to go out. So the current thing we have written is if it's both of these, if it's sunny and it's the weekend, it's perfect for a picnic. Else if is sunny or is weekend, it's still a nice time to go out. So I guess even if it's raining, if it's not sunny on the weekend, we'll still say we can go out for our picnic. Okay, so add the else if to check if it's either sunny or it's the weekend. If either of those is true, we print out it's still a nice time to go out. That's what we have written right now. If this is true or this is true. So an else if is like us asking a follow-up question. Okay, and I'll talk about that a little more here in a second. Finally, if neither are true, stay indoors and relax. So our catch-all, our else, we'll say else, see out that guy. All right. So looking at this structure. Now, what I have told you up to this point is that it's never wrong to use curly braces, right? I've told you that you should always use the curly braces. But technically, I have omitted some curly braces here. There in the C++ language, C, C++, Java, C#, there is no such thing, that can't be grammatically correct, but let's roll with it. There isn't a thing else if. Those are two separate things. We know about else's, we know about ifs. This else if right here is equivalent to saying else. The same thing as saying that. So if this is true, do this. Otherwise, let's ask another series of questions. So else, if it's sunny or the weekend, we'll output this. Otherwise, do this. Those mean the identical things. Now, having said that, this is kind of similar to our discussion about, the types of variables you should use, int versus long versus floats and doubles. We talked about ints are the common variable type for holding whole numbers, unless they're not quite big enough. Yet doubles are the common way, the widely accepted way of holding floating point numbers. Again, because we live in a world now where we don't care about memory. So we're no longer good stewards of our RAM. But long time ago, we had to be. Okay, so we just choose int. If we're holding whole numbers, we choose doubles if we do that. What I'm telling you is that the common practice for a modern programmer is to always use the curly braces unless it's an else if. And the reason for it is we've already talked about the syntax for an if statement is if Boolean expression statement. And if is a statement. This guy right here, that whole thing is a single statement. It's an if statement. All right. But I would say it would be fairly rare to see somebody write it that way. The way somebody would probably write it is that else if. That guy. This is the single statement. So not only did we not use curly braces there, we also didn't kick it down a line. So we deviated from my advice. All right, do whichever one you prefer, but I would say it is common for an else if to write it this way. Some programming languages actually have an else if keyword. Sometimes it's elif, elif, something like that. Okay, but all the rules are the same. Whether we're dealing with an if, an else, or an else if, the rule is it's followed by a single statement. So if you know what a statement is, you know whether or not you need the curly braces or don't need the curly braces. My advice to him was always use the curly braces so you don't have to ask the question. Now I'm kind of tacking on to the end of that F that, hey, look, if it's an else if, I'm telling you an if is a statement, a single statement. So you could choose to not use the curly braces in that point, in that part, to make it look a little more structured. Because when we had that extra indent with the more curly braces, it looked weird, even though it was consistent with the way we've been writing stuff up to this point. They both mean the identical thing. Promise.
When I did 2.3, it kept on giving me it kept on printing out the message even when I set is tired to false and set the if statement to be the opposite of it.
I'd have to see the code. I have to see the state of the variables and the thing. Similar to the last time, I'm sure there was some deviation in what you wrote. So if you want to keep that code to the side and at the end, I can look at it and tell you what went on with it. All right. Part 4, evaluating conditions. In this part, you'll put together, I did write this, right? The stay indoors and relax. Yeah, got it. All right, so last part. You'll put together multiple Boolean expressions using operators. So we're going to have some variables. So whenever somebody says hard code variables, I'm going to teach you how to read something in from the user today, which isn't difficult, but hard code a value means define the variable, force the value in there. You're not reading it in from the user. A lot of times that's the easiest way to learn initially. So you're not having, you could test your program quickly without having you to constantly having to type input in for your program to run, but I'll show you how to do that anyways today. All right, so we'll define a couple of variables here. All right, so we have is citizen, we have age, which is an integer, and we have has voter ID, which is a Boolean. Write an if statement using Boolean operators to check if a person is eligible to vote. A person is eligible to vote if they're a citizen. So let's go ahead and write that first part. We'll just let it unfold. If is citizen. They are at least 18 years of age. If all conditions are true. So to make something so that all conditions are true is true, we use ands, right? So if they're a citizen and they're at least 18 years old, and age is greater than or equal to 18. So that's a Boolean expression, right? That's going to be true if they're greater or equal to 18, false otherwise. So if they're a citizen and they're at least 18, and they have a voter ID, has voter ID. If all those things are true, we're going to print out you are eligible to vote. Otherwise, print out you are not eligible to vote. All right. So if we're a citizen and we're at least 18 years old and we have a voter ID, we're eligible to vote. If at least one of those things is false, we're not eligible to vote. So right now, we are a citizen, we have a voter ID, and we're at least 18. So if I run it right now, we are eligible to vote. You are eligible to vote. If everything else is the same, but I'm now 14 years old, we're not eligible to vote. You are not eligible to vote. Okay. So I think, is that all the assignment? Yep. So that's the assignment. We messed around with some variables in there for playing with it. So now what I'll do is I'll go and I'll save my code. If this is the first time you're saving, it'll ask you to name your project. So I'll just call this CSC2000 underscore fall 2024 underscore homework 2. That's what this is, homework 2, right? So I'll name it that, and I'm putting it in my projects folder. So I'll hit save. Once you've saved it, now you can hit this button that says share, and it gives you this link. And once you have that link, Now you can submit that link as your code. So if I go on to Slack here, and here's our Slack channel, and I go ahead and paste that link in there, any of you click on that, you'll see my current state of my code. Even if I go and start changing it, it takes a snapshot of the current version of the code. Make some sense? Okay, so moving forward, when you submit code, that's how I want you to submit it. If you're using a different technology other than online GDB, I want a GitHub link. If you don't know what I'm talking about, use online GDB. All right. We'll talk about GitHub when we start messing with Unity, the game engine, next semester. Go ahead.
In the if statement, if you get rid of the middle parentheses, does it apply the greater than or equal to the citizen?
So if I do that, it'll still, I think, order of operation work in this case since we don't have numbers on either side.
So if you put two numbers you want, like,
Oh. So like, for instance, if we had age is greater than or equal to 18 and yeah, I don't know. Call it dad's age. Dad's age is less than or equal to 1,000. All right. So now all four of these need to be true. If you're a citizen and you're at least 18 and your dad's not over 1,000 and you have a voter ID, you're allowed to vote. So you don't need the parentheses, but I would put that into a similar category as the curly braces. It's cleaner when you glance at it to see those parentheses there so you know that kind of goes together rather than relying on the order of operation to make things work. And you've probably seen that kind of stuff like on TikTok before where it's like only geniuses can solve this math problem, where it has like 1 + 3 × 2, something like that. But it doesn't have any parentheses and it relies on you knowing the order of operations that multiplication comes before addition. All right. So rather than memorizing it, put parentheses to make it exactly what you want. All right. So going back to this here. I not put up the self-evaluation in here? All right, I'll have to put it up after class. So your next homework assignment is up. I'm going to talk about the stuff you need for that here in a second. We're dealing with loops. Here at the end, notice it says submit the self-evaluation as well as a link to your code. Okay. The self-evaluation I'll put up here. I usually have it up there ahead of time. I must have just forgotten it, but I'll put it up today. It effectively is your way of describing to me your experience, because some of you might spend 48 hours on an assignment and have very little to show for it. And I assume you want points. So you can kind of tell me, hey, this is how long I spent on it based on my effort. Hey, I worked really hard on this. This is what I think I deserve. Based on my solution, I have a blank sheet of paper. So this is what I deserve if you're only going off the answer. Okay. And then give me a little bit of a commentary on what you tried, what went wrong, what went right, that kind of stuff. So it's your mechanism for begging for points. All right. But frankly, the secret is I don't really pay much attention to it from a point perspective. I just have you kind of self-evaluate to like, did I really put in the time for this assignment or did I phone this in? Right. So it's as much of a wake-up call for you as anything else, but it gives me a rationale for trying to figure out what you were trying to do and maybe give you a little feedback as to, okay, this is where you know, as soon as you took that left turn, you were going down a bad path. All right. So give me both of those things. There'll be a link over here on the left that just says self-evaluation. There's like 3 questions. It takes 2 minutes to fill out. All right. So now let's get into some other stuff. Sure. All right. All right. So first of all, reading in from the user. I'm going to go back into the code here. Now, if the way we write out to the user is using C out, how do you think we might read in from the user? Maybe C in? All right. So I'm going to go ahead and gut all that. Remember, the link that I gave you will have all that code still in there. Okay, I've now created a new branch. All right, so we're going to say int age, and you can give it a starting value or not, but I'm going to give you an example of this is when you might not want to give it a default value. So we're going to do cout, please enter your age. And notice I didn't kick it down a line here. We're going to kind of prompt the user for this, right? Then I'm going to say cin age. So I defined a variable to hold my answer. I prompted the user for the answer, which is only for our eyes. That's not programming logic. That's just, hey, telling the user what you want. Then we read in from the user the age. Notice the double arrows go the other direction. Then we outputted a string you entered, and then we tacked in the value that age currently holds, which should be the value we read in. Enter your age. I'll put 15. I'll press enter. It says you entered 15. So we got a value in for the user. And because age is an int, we can do mathy stuff with it. So if I print out age plus 5, it'll do math with that. So now it'll print out a 20. So it takes the type here. Cin is smart and says, okay, you wanted me to read a value into this variable type. We're in a strongly typed language. Because you're putting this guy inside of a variable of type age, you must be reading in an int. Make some sense? All right, so now we know how to read stuff in from the user. All right. So let's go and talk about loops. Let's put like a little example here. Int age, cin age. All right. Okay, so again, remember, way human beings solve problems. We remember stuff, we ask questions, and we do repetition. All right, one of the ways we accomplish repetition is through something called loops. Okay, so loops, call this one of the mechanisms by which we accomplish repetition. There are 3 kinds of loops. You could actually probably make the argument in more modern languages that there's like a 4th or a 5th, but for right now, let's just operate off of this. We have a while loop, a for loop, and a do while loop. All right, and we'll talk about each of these in turn, but I'm going to kind of give a little definition of the type of loop this is. While loops are pre-check loops. For loops are pre-check loops. Do while loops are post check loops. Okay. I'll explain what that means here in a second. So let's start off with a while loop. So this is a pre-check loop, which means we check the Boolean expression before executing the body of the loop even once. While loops lend themselves to problems where we do not know how many times we need to loop. That is to say, we don't really have a preconceived notion of how long until that Boolean expression becomes false. So if I go back to the previous thing here, we'll say loops continue to repeat until the Boolean expression is false. So kind of like an if statement where we say, if something is true, do this. A loop is really kind of, as long as this is true, keep doing this. And each time through, it checks that Boolean expression again. All right. So one statement I'd say is you can really accomplish anything involving loops with any of the three loops. So just because a loop kind of lends itself to something doesn't necessarily mean that's the only tool for the job. You can think of it kind of like duct tape. You know, you could apply duct tape to all sorts of tasks that it wasn't designed for. All right, so a while loop, pre-check loop, which means that it executes 0 or more times. We ask that question. We execute the Boolean expression before we ever execute the body of the loop. So if it's false the very first time, that loop will not do anything. Lends itself to problems where we don't know how many times it's going to have to spin. An example might be until some key was pressed. We don't know how long until a key is going to be pressed, right? So maybe we try to do something, key hasn't been pressed yet. Maybe we wait 3 seconds, loop back around. Has it key been pressed yet? Has it key been pressed yet? Has it key been pressed yet? It's out of our control when the key's finally going to be pressed. So we don't know, but this is the type of loop that might lend itself to that. All right, let's steal that slide. Now we have a for loop. For loop is also a pre-check loop. So it uses that same behind the scenes mechanism where we check the Boolean expression first before we ever execute the loop. So this guy will execute 0 or more times. For loops, though, lend themselves to problems where we do know how many times we need to loop, like counting problems. Do something 10 times. Do something 3 times. Something like that. Where while loops might lend themselves to do something until some condition is false. Even though you could use either one of them to solve either kind of problem. Oh. So then we have a do while loop. This guy is a post check loop, which means we check the Boolean expression after executing the body of the loop at least 1 time. So that means in a do while loop, the body of the loop will always execute at least once. Now, this will be the rarest loop for you to use in terms of your programming, but it's actually let's call it the correct loop for a really common thing, that is authentication. I know all our browsers and stuff save our passwords and things like that nowadays, but whenever you go to a site, you got to give its username and password at least once before. So it's going to say, give me your username and password. That might be in the body of the loop. Then it spins up and says, did you give me a good one? If yes, we'll move past. If no, let's, so you'd use probably a not operator. If the password you gave me is incorrect, I'll ask you again. Keep doing that till you finally give them a good password. Okay? So authentication would be an example of something that we definitely want to have happen at least one time, because we don't want it to shut us down before we even have the opportunity to try to log in. Okay. Now, syntax for these guys. I'll leave that. Reading. Here, let me show you a multi-line comment. So I mentioned last time, or a couple times ago maybe, that you can make something a comment in your code by using 2 front slashes. So any C-based language lets you just put front slashes in front of things like that. So now you can still see the code I wrote, but it's not part of the program. The reason I did that is when I'm testing this and showing you loop stuff, I don't want to have to keep typing my age in over and over again. Okay. But let's say you have a bunch of lines of code like this. It's only 4, so it wasn't the end of the world, but you can do that. You can wrap all the code you want to put in a comment inside of a front slash asterisks, no space. They got to be together, and an asterisk front slash. Actually, you know what? They don't. Because a lot of times you'll see people mark it like this. So I guess it's technically they're still together. But that really highlights the idea that I wrapped it in a comment. All those extra asterisks are not needed. The important parts are that guy right there, final asterisk slash, and this guy right here, the opening asterisk slash. So that's for a multi-line comment. All right, so let's look at our various loops here. So let's say while loop syntax. So while loop syntax, I'll give myself a multi-line comment here. And that is while Boolean expression, opening curly brace, 0 or more statements. And again, just like an if statement, technically these curly braces are not required if you're only going to do one thing. Same rules as an if statement. And the same advice, always use them. Okay? So while this Boolean expression is true, keep executing that over and over again. And it will check this Boolean expression the first time. So I'm actually going to use this for a counting problem so you can kind of see the comparison with the for loop. So I'm going to say int count is equal to 0. So I'll create a variable to remember my current count. While count is less than 10. Cout count. What will the output of this program be? Remember, you got to walk the program one line at a time and resolve those variables. Tell me, what do you think the output of this program is going to be? Go ahead. Yeah, this is an infinite loop. Why is it an infinite loop? Remember, it's a pre-check loop. I've created a variable called count. I've started it off at 0. Then we ask the question at least once before we get into the body of it. What's the current value of count? It's 0. Is 0 less than 10? Yeah. So what are we going to do? We're going to print out 0. Then we spin back up. What's the current value of count? Still 0. 0 less than 10? Yep, it's still less than 10. Print it out. 0 less than 10, 0 less than 10, 0 less than 10. Common mistake for beginning programmers is not updating their variable inside of the code. So this would be an infinite loop, but we'd get a lot of printouts before it finally bailed on us and said, hey, you've used up too much system memory or something like that. So if I run this guy, notice it's printing stuff out for a while, printing out the value of count. All right, so now I got to go hit stop. So what we really want to do is inside here, we want to say count is equal to count plus 1. We are updating the value of count using the single equal sign, the assignment operator, to be whatever count currently is plus 1. For those of you who have coded before, this is the same thing as saying count plus plus. I don't care if you use that now, but I'm going to talk about that later. I'm not going to, the plus plus is something you might think you understand, but I'm guessing you might not fully understand. So kind of trust me on that. But for right now, we're going to say count is equal to count plus 1. Single equal sign is the assignment operator. It assigns whatever this value is to this variable. So the first time through, count is 0. Is 0 less than 10? Yep. Print out 0. Then 0 becomes 1. 1 less than 10? Yep. Print out 1. So on and so forth. We see 0 to 9. Because the very last time, 9 became 10. We spun back up. Is 10 less than 10? Nope. So we never actually printed out the 10. If we just threw an equal sign in here, though, we'd get the 10. It would go through 1 additional time, and there's our 10. All right. So that's an example of a while loop. Now, one thing that's going to be interesting, since most of the loops we use in our computer programs are really counting type things, repeat something so many times. That whole idea of a while loop not knowing how many times it's going to repeat is actually somewhat rare for us to have in a program. Not nearly as rare as a do while loop, but a majority of the loops you're going to have are going to just say do something some number of times. So your go-to loop likely will be a for loop. Okay, and I'm going to explain that. We'll probably get into the weeds of that next class, but I'm going to give you the syntax here. So a for loop syntax is for. We're going to call this guy var, followed by a semicolon, followed by a Boolean expression, followed by a semicolon, followed by a change var. Opening and closing curly brace.
Hang on. So is there like a 6, 5, 4, 3, 2, 1, etc. off screen on the console?
Yeah. Oh, yeah. You mean those guys?
Okay. Yeah.
All right. So what I'm going to do here is I'm going to rewrite the same logic, almost the same logic. We'll talk about variable scope next class, but I'm going to write it in a for loop. I'm going to say for int. I'm going to say call this guy count2 because it'll currently conflict with our other variable called count. So int count2 is equal to 0. Count2 less than 10. Count2 is equal to count2 plus 1. This loop does the identical thing to this loop. So there's our 0 to 9 followed by a 0 to 9. So notice that a for loop kind of drags in a lot of the individual pieces that a while loop has. Almost every one of our counting loops is going to have some value we're remembering. It's going to have a Boolean expression, and it's going to have a way of changing that value. So a for loop puts them all together. And you can actually define multiple variables in here if you wanted to, and you can change multiple variables, but you can only have one Boolean expression. Don't overthink that right now. You're not going to have that in your homework, the more than one variable thing. The quick perk of this, and I'll talk about it more next class when we talk about variable scope, is with a for loop, after this loop's done, count2 no longer exists. It was kind of like this quick throwaway variable that we just used to do something so many times. Whereas with a while loop, because this variable was defined outside the while loop, it's still around after the while loop's done. And maybe that's what you want. But there is a difference between these two, even though the output is the same. currently. Okay. We only have a minute left, so let me show you the do while loop so you have everything to do your homework, and we'll talk about this stuff in more details next time.
So the homework's due Thursday?
Yep. And it's already up. I always have the due dates for it up on Blackboard. All right, so a do while loop is, so we're gonna go ahead and say int count 3. We'll start that guy off at 0. And we'll say do cout count 3. Count 3 is equal to count 3 plus 1. While count 3 is less than 10. The semicolon at the end. So we defined a new variable count 3, similar to what we did with a normal while loop. Then we did this stuff. We outputted count 3, then we changed count 3. Then we asked the question. It's a post-check loop. So this will execute at least once before we ever check the Boolean expression. It'll give us the same result this time because we happen to not fail on the first time through. So if I run this, there's our 0 through 9, there's our 0 through 9, there's our 0 through 9. Okay, but the thing I'll throw out there is if I change count 3 to 10, which for our other ones, if count 2 was 10 and count 1 was 10 or count was 10, it wouldn't print out anything, right? This guy will still print out the 10 because it executes the body at least one time. There's that 10. All right. So I'll go ahead and save this. I'll share this code on Slack. And I'll go ahead and I'll update the assignment with it as well, with kind of like, given this example code. So you have that link. You'll be able to do the homework with what we just discussed. So there is the loop code. So that's in Slack. And like I said, I'll update the assignment and put the self-evaluation stuff up. All right. So for next class, do the loop assignment. We'll go over it again. And I want to put a reminder in here. I want to talk about variable scope. All right. Questions, comments, concerns, bribes.
Is it okay if we go over that problem I was having with the homework?
Say this again. I'm sorry.
Is it okay if we go over that problem I was having with the homework?
Yep. Do you have like 2 minutes you can hang out so I can answer this guy's question real quick?
Yeah.
Okay. So just chill there. I won't disconnect on you.
Again.
Let me stop the recording though, so I don't forget.
Detailed.